All right, I could get most of them.
So, here's your cell.
The mitochondria.
Cells have like little bits and bobs in them, right? Like
Maybe
nucleus stuff.
the ribosomes, Golgi apparatus.
Yeah, but I don't know how to draw any of those. The Golgi apparatus is like a little spirally thing, isn't it?
The ribosomes.
No,
I think.
ribosomes are on the rough ER.
Yeah.
Okay.
I have no idea what you guys are talking about. It's cool to know there's more stuff you can learn. So, I have an inflow into this thing of 10 femtoliters per, what's it say? Hour.
Yeah.
And I have also an outflow of 10 femtoliters per hour. Okay, what's the concentration of stuff flowing in?
0.2.
0.2, which you can think of as 2 femtoliters per 10 femtoliters. Right? So if we were doing a more honest, like, if we were more honest with our units, that would be something more like, let's see, so I did 0.2 femtoliters, right? What's a reasonable blood alcohol content? So 0.2 is 20% alcohol, right? If your blood is 20% alcohol, you are dead. DED dead.
You're basically an alcoholic beverage at that point.
Yeah, at that point you're schnapps. Right? So your blood alcohol content is probably not 20%, but instead is 0.2%. Like 0.08% is legally intoxicated. Right? So if you're pushing 3 times that, you're like fall down drunk. Right?
So is that what you were saying in the problem, is that it's 0.2%?
No. I just didn't calibrate the units in the problem.
Okay.
I said, suppose it's 0.2, right? So if it's 0.2, right, what we're really gonna be asking about is, when are you dead? Right? Like, how long do you have to get this alcohol out of your system before your cells are all dead? And the answer is probably not very long. If I was doing a more realistic problem, I probably would have 0.2% instead of 0.2. You guys see that?
Mm-hmm.
Okay. So, units aside, I'm just going to do this the way we've got it. Okay. What do I model? Like, what are the rules of compartmental analysis? What are the 2 major lessons?
Don't model concentration.
Don't model concentration. So, what am I going to model instead of concentration?
Amount.
Yeah, model the amount of the stuff. So I'm just going to say, all right, let A of T be the amount of alcohol in the cell at time T. Right? So this is just me saying, yo, I'm not modeling a concentration. Cool. All right. What else was given to me in the problem? Was there another thing?
The volume.
Yeah, they said the volume of the cell
Yeah.
was what?
80 femtoliters.
80 femtoliters. And that one I did actually go look up. That's about reasonable for blood cell.
Blood cells look nothing like
All cells look like that.
that. Okay.
Give or take. Besides, cells are
With an
myth.
experimental
You
error.
can't see these. Okay, anyway, next thing. So I got a volume of 80 femtoliters. What else was in there? What did it start at?
0.
Yeah, it
Yeah.
started with 0 alcohol in it, right? So what's your A at 0 then?
0.
Right? Okay. Now, what was the second rule of compartmental analysis?
That's the amount is the, yeah, in
Yeah,
minus the
so
amount.
the rate of change of the amount, so dA dt is the in. So how much alcohol are you getting in here? 0.2 femtoliters per femtoliter, right? Times 10 femtoliters per hour, right? So that's going to be 2 femtoliters per hour of alcohol gain. So that's 2 in 10 times 10. Guys all with that? And then how much are you losing?
You're losing 10 diluted femtoliters.
Yeah, I'm losing 10 femtoliters an hour, right? That's my outflow rate. And then how much of this stuff is there in there?
The amount in milliliters divided by 80.
Good. This should be A over 8. You guys with me on that? Okay, and then rewrite. So if you rewrite, you get dA dt is 2 minus A over 8. And then there's a whole mess of ways to try to solve this.
T's on one side, A's on the other.
Yeah, you could add A over 8 to the other side, right? And then do,
Formula.
yeah, apply the, what are you solving there?
I don't know what the name of the formula is, I just don't know how to do it.
Okay,
First order.
it's a first order linear
non-homogeneous differential equation.
non-homogeneous differential equation. Right, so you'd move it over, you'd solve the homogeneous version, and then you'd guess mu times that, and then you'd sub that in and solve for mu and get some answer. That's one method.
Well, I was thinking, couldn't you just put the A over 8, add that to the other side, multiply the dt over, like just separate it?
Yeah, you could also separate variables. So when you separate variables, what you need is something times dA equals some other thing times dt.
So it wouldn't work then, 'cause you're adding it.
So yeah, you don't want to add the A over 8, but you could do this. This is what I'm going to do. Just go. So I'm just going to take this whole equation and multiply it through by 8. So I got 8 dA over dt equals 16 minus A. Sure. And then I'm going to multiply by dt divided by 16 minus A. And so here I'm going to end up with 8 over 16 minus A. dA is what? 1 dt. And then yeah, slap a d-eater on there. Squiggle, squiggle. Get a t plus some constant, right? And on this side, what do you need?
No, you can take the 8 out.
Okay, you can pull the 8 out.
So it would be 8 times the natural log of 16 minus 8.
Yeah.
Minus,
Yeah, so I would advise that on tests at least you be careful and write down the use of you're doing. Just because it gets to be a pain in the ass for everything else if you drop a minus sign in a stupid spot, right?
I did do that, but I missed a 2 on one of them. It was a point off, so I didn't do that.
Yeah, and it made all, like, if you dork up one of the little integrations at the beginning, oftentimes I've designed the problem so that it flows easily. And if you dork something up at the beginning, then like exponents don't add up right, or things don't cancel, or so just be slow and careful with your U substitutions. It'll save your life. All right, so I need a minus dA, so I slap a minus sign in there and out here. And then I think I got a minus 8, the integral of 1 over u du. Yeah. Okay, so I got minus 8 natural log of the absolute value of 16 minus a equals t plus c. So then divide by 8. So multiply by negative an eighth, I guess. Get the natural log of the absolute value of 16 minus a is minus t over 8 plus a constant. And then slap an e to the stuff on both sides. So you get 16 minus a is e to the minus t over 8 times some other constant, calling it k for kicks. And then what?
Minus 16, divided by minus 1.
Perfect. Subtract 16, multiply by negative 1, get a is 16 minus k e to the minus t over 8. And then what? Okay, then you need to find k. How do you find k? Yeah, so I know a of 0 is 0, so if I plug 0 in, I should get 0 out. So I figure out that k has to be 16. So I get a is 16 minus 16 e to the minus t over 8. And then what was the second part of this question?
Initial value. Not really, but
At what point
Find-
does alcohol reach this,
yeah.
alcohol content of the cell reach point of
Yeah, I want to know, when does the alcohol content of the cell get to 0.08, right?
Mm-hmm.
So I know now the amount of alcohol in the cell, right?
Mm-hmm. So you have to do 0.08.
And I'm looking for when does the concentration hit 0.08.
Wait, because you said content. So I assumed you were talking about just the total content.
Yeah, you
Ah.
did say content.
I did say content. I apologize.
Uh-oh.
Just gonna scratch it.
Obviously,
Guess we
I
should
meant
all get turned on that.
concentration.
Guess we all gotta.
That's what screwed me out.
That's what screwed
I
you
know,
up.
I could've
That's
said
what
it.
screwed
Show of hands for that's what screwed me up.
Okay.
The rest of you are very honest.
No, I definitely dorked up a negative sign.
Okay, I'll give you a couple points for that. I think I took off 2 points for people thinking that I meant content instead of concentration, even though I said clearly content. So, if I wanted to figure out when the concentration hit 0.08, what would I do?
I can tell you.
Find how much is in it, or the concentration, the amount.
Yeah, so if you want to figure out when the concentration hits something, you need to know what the amount is that goes with that concentration. You guys see that? So if the concentration 0.08, then the content is 0.08 times the volume. You guys see that? So this is really when does the amount hit 6.4. And so then you take 6.4 and set it equal to what?
That
Yeah,
stuff.
that equation.
Solve.
and then solve, figure out t is something.
What was T?
I found 4.08 hours.
That's, okay.
So, do we wanna find out when the amount hits 6.4, or are we trying to find out when the amount hits 0.08?
That's a fair question. The way I worded it on the test is ambiguous and, yeah, an autocorrect problem. I must have misspelled concentration and just hit whatever. Yeah, that should have been concentration, reach 0.08.
Yeah, I did. I did
My
it
bad.
on time, but
That's-
I've also definitely dorked up negative signs.
Okay, so if you feel like that cost you a couple points, I'll give you a couple points.